video, we are going to determine the trigonometric Fourier series for such type of graph. So our graph is like this, like 0 to 1 it is a spike, and 1 to 3 it will be the 0. Okay. So for trigonometric Fourier series, these are the basic formulas. First, let us look into this, like f of t, which is the trigonometric Fourier series, equals to a naught plus summation n1 to infinity an cos n omega t plus bn sin of n omega t, and all brackets are enveloped. Okay, where a naught, which is the DC current, which is equals to the 1 by t. T here is 1 period. Okay, 1 period means, see here, this is a commonality graph, right? Here to here it is the same here to here it is the same, means this is known as a 1 period of time. This is known as a 1 period of time, means a commonly repeating graph in a time period, like in 1 period of time, is known as the t, which is nothing but a periodic signal. At there I have given the idea to you. Okay, like 1 by t, 0 to t, f of t dt, where an is like coefficient of cos is 2 by t, 0 to t, f of t cos n omega t dt. Bn is 2 by t, 0 to t, integration 0 to t, f of t sin of n omega t dt. Okay, these are the basic formulas we need to note. Now let us go for the data for 1 period t, like time t. I'm zooming out so that we'll get a clear picture here. Data for 1 period time t. T exists from 0 to 3. Let us take 0 to 3 the time, means the t units are 3. Now f of t exists only for 0 to 1. When t lies between 0 to 1, it will be the t. Otherwise from 1 to 3 it will be the 0. Okay, where angular frequency omega naught, which is equals to 2 pi f, omega naught, which is equals to 2 by t. F we can write, f is direct inversely proportional to t, right? Like f equals to 1 by t, omega naught equals to 2 by, where t is 3 units, like 2 by 3. We have derived the data of 1 period t. Now let us go for the things like DC coefficient a naught, a n, b n. Let us find first DC coefficient a naught, which is equals to the 1 by t, 0 to t, like integration 0 to t f of t dt. So t is the 3 and f of t is for the 0 to 1 only. Okay, t into dt. Do so, you will get a naught as 1 by 6. Now calculate the an. Now let us calculate the an, which is equals to the 2 by t, integration 0 to t f of t cos n omega t dt. T is 3. Okay, integration is only for 0 to 1, because from 1 to 3 it is a 0, right? Doing the things on 0 will give results as 0. So in order to making the things on complexity, just do for 0 to 1 only. Okay, f of t is here t cos n, omega is 2 pi by 3 t dt. Let us take this whole thing to alpha. Now when you do so, here just alpha t changes to alpha t. Okay, t into cos alpha t dt, which is like t sin t by alpha. Okay, like this thing first you need to do, like t sin t by alpha cos alpha t by alpha square. Okay, you need to do so, equals to the integration of uv, right? So apply here. When you do so, you will get this thing. Okay, apply the limits. When you apply, so 0 to 1 only, right? When you apply, you will get this thing. Substitute alpha as n 2 by 3. you will get an as like this. Now let us go for the bn. Bn is 2 by t 0 to t f of t sine omega t dt. Same process here, do so. You will get the bn. Now final Fourier transform like Fourier series is f of t 1 by 6 summation n 1 to infinite an cos 2n like this. Okay, this is the final Fourier series. I hope you got the idea on this first thing. Just a calculation part is bigger here. Okay, it is a simple thing. Let us go for the second problem. You will get the more depth idea of this. Okay, determine the trigonometric Fourier series for this. When the graph is like -2 to -1, it will spike. Okay, rest from -1 to 0, it is rest. 0 to 1 again, it will give it will high spike. Okay, again from 1 to 2 it is rest, means it is a repeating graph for the 1 period t. T exists from, let us take 0 to 2. T is 2 units. F of t is like 1 when it is from 0 to 0 for when t 1 to 2. Okay, omega naught is 2 pi f, where f we can write as 1 by t like this. 2 pi by 2, omega naught is pi. Let us go for the DC coefficient. A naught is, this is a formula, apply the t. T means 2. What we got? T as 2 units, 0 to 1 dt. A naught is 1 by 2. Okay, let us go for the calculation of an and bn. When you calculate the an, this is the an formula. Apply the things. T means 2. F of t is 1 when it is 0 to 1. Cos n pi by t. Okay, 0 to 1 cos n pi by t dt. You will get the integration of cos means sine, obviously. When you apply the limits, sine n pi minus sine 0 will all result into the 0. Therefore, an is 0. Let us calculate for the bn. Bn is 2 by t 0 to t f of t sine n omega t like omega naught t dt. F of t is 1, 0 to 1, 2 by 2, which is 1, sine n pi t dt. So for the sine, it is a minus cos. When you apply the limits, it is like 1 minus cos n pi. Since cos n pi, we can write as -1 power n. Okay, like cos like cos 0, it is like 1, cos pi, which is like a -1, cos n pi, which is like a -1 power n. Okay, this is how the things will be. 1 minus of -1 power n pi. For the even powers n, bn is 0. For odd n, like bn equals to 2 by n pi. Okay, for odd n, let us take odd n as 1 only, n pi, which is like minus into minus plus 2 by n pi, right? For the even powers, let us take 1 of -1 power 2, let is. So, which is like the 1 minus 1 n pi, which is equals to 0. So, for the even powers, bn is 0. For the odd powers, it is like 2 by n pi. Final Fourier series, you can write like this. This is the final Fourier series you will get. Let us go for the extension of this problem. In this extension, in the exam, along with this trigonometric Fourier series, sometimes by your bad luck, you might got magnitude and phase spectrum. Like those people may ask in the paper, like draw its magnitude and like phase spectrum. Then it is a very simple topic. So see here carefully. Magnitude spectrum is plot of Cn versus n, where Cn is under root an square plus bn square. Okay. we are seeing right an, which is the coefficient of like cos, right? And bn is which is the coefficient of sine, right? So here this coefficient square under root, when we calculate, we will get the cn. So for this formula, an is 0. Okay, bn exists for in terms of odd only, right? Bn square odd. B 0, anything will be a 0. We are left over with the b square, right? And under root square will be the simply this thing only, bn odd, like 2 by n. Let us take n as 1, 2, 3, 4, 5. Okay, samples. Cn is bn exists for the even. Bn exists for the odd things only. Evens are 0, 0, 0. You will keep 2 by 1 into pi, like 2 by pi, 2 by 3 pi, 2 by 5 pi. When you plot the graph, what we need to plot in the magnitude spectrum, we need to plot the graph for Cn and n. Plotting the n is easy, like 1, 2, 3, 4, 5. Now for the Cn, at the 0, it is like the 0, okay? 2 by pi, which is like, for the 1 it is like 2 by pi. For the 3, it is like 2 by 3 pi. For the 5, it is like 2 by 5 pi. Something a gradual decreasing graph, okay, you will get. Okay, one thing is done. Let us go for the phase spectrum. In the phase spectrum, so which is the plot of pi n versus n. Pi n is the representative of the space spectrum, which is symbol as pi, okay, where space spectrum, which is equals to the tan inverse minus bn by an. So n exists only for the odd. Okay, tan inverse of 2 by n pi, an is 0, something into 0, like minus 2 by 0, which is like minus infinite. So minus infinite, tan inverse of minus infinite means you can write as tan inverse of tan minus 90, okay, which is like minus 90 for every like phase value, which is like minus 90 in the one case, 3, 5. Otherwise it is a 0 for the events, okay? When you plot the graph like 1, 3, 5, it is only exit. For 2, 3, like 2, 4, 6, it will be the 0, okay? This is how the trigonometric Fourier series will be, and drawing of its magnitude and phase spectrum. I hope you got the idea on this. If you learned anything in this video, please do a like and support by subscribing. Thank you for watching this.